Hello, my dear children. In the previous videos, we have discussed the concepts of exercise 2.4. I hope you have understood, you have learnt well these concepts. They are very useful for the exercise 2.4. What are the concepts you have learnt? First one is factor theorem and the second one is factorization of a quadratic polynomial using splitting the middle term method. We use these 2 points only throughout this exercise. Okay, my dear children? Right. Now come to the sums in exercise 2.4. Exercise 2.4, page number 41. Page number 41. So first Roman, there are four parts are there. In the first Roman, there are four parts. I am explaining fourth part. You try the remaining first three parts. Okay, my dear children. First Roman, fourth part. I am explaining here. Understood, my dear children? Right. Examine whether the polynomial x plus 1 is a factor of the polynomial x cube minus x square minus of 2 plus root 2 of x plus root 2. We have to check, we have to verify whether this polynomial is a factor of this polynomial. Understood this question, my dear children? I told you many times, my dear children, first of all, read the question till you understand the question. Okay, my dear children. So, first, come to the solution part. Let us consider given polynomial is p of x. Here, they did not give. It is a p of x. We assume that p of x is equal to x cube minus x square minus of 2 plus root 2 of x plus root 2. We are assuming that this is p of x. Understood this step, my dear children? Right. Now we have to find 0 of x plus 1. We have to check this is a factor or not. That is why we are finding 0 of this linear polynomial. How can you find the 0 of a linear polynomial? We have to write this equation. Given linear polynomial is equal to 0. We have to write this equation to find 0 of a linear polynomial. Then we have to solve it. So from this equation we get x is equal to minus 1. If we are moving this plus 1 to RHS, we get here minus 1. So what is the value you got here? For value of x, minus 1. So we have to substitute minus 1 in the given polynomial. It means we are finding the remainder when it is divided by this polynomial x plus 1. So put x is equal to minus 1. Put x is equal to minus 1 in p of x. We are substituting x is equal to minus 1 in the polynomial p of x. Then we have p of minus 1. In this polynomial, we are replacing x by minus 1. Understood this point, my dear children? Right. So p of minus 1 is equal to, here x cube is there. So minus 1 whole cube minus, what is second term? X square. So minus 1 whole square minus 2 plus root 2 of x is there here. So into minus 1 plus root 2. Understood this step, my dear children? In this step, I replaced x by minus 1. Okay, my dear children? After that, we have to simplify these terms. How many terms are there? 1, 2, 3, 4. Total 4 terms are there. I told you many times we had to simplify each and every term separately. So here, what is the first term here? Minus 1 whole cube. In rough work, I have done that one. Minus 1 whole cube value. I found here the value of the first term. Minus 1 whole cube means minus 1 into minus 1 into minus 1. Minus into minus. What do you get here? Plus. Plus into minus. What do you get here? Minus. So finally you get sign minus. Numbers 1 into 1, 1, 1 into 1, 1. So numerical value is 1. So finally, the value of minus 1 whole cube is minus 1. That is the value of the first term. And after that, minus 1 whole square. Let us find the value of this term. So minus 1 whole square means minus 1 into minus 1. Isn't it, my dear children? Right. So minus into minus. What will you get here? Plus. So I am not writing plus sign here. 1 into 1, 1. Understood this point, my dear children? Right. So I found the values of these two separately in rough work. Now I substitute these values here. Minus 1 whole cube. What is the value of minus 1 whole cube? Minus 1 minus minus 1 whole square value. What is the minus 1 whole square value? 1 plus minus of minus into minus. What do you get here? Plus. So plus 1 into this term. Then what we get? The same term. 2 plus root 2 only. Plus last term is root 2. Understood this step, my dear children? Right. Now here minus 1 minus 1. What will you get? Minus 2. Here plus 2. Minus 2 plus 2. Gets cancelled. These terms gets cancelled. Understood this point, my children? Right. Next, root 2 plus root 2. What will you get here? 2 root 2. Finally, the value of p of minus 1 is 2 root 2. Is it a 0? No, it is not a non-zero value. So, it is not equal to 0. Means we are not getting remainder 0. So, by the factor theorem, we can say that x plus 1 is not a factor of x cube minus x square minus of 2 plus root 2 of x plus root 2. Understood, my dear children? Right. Now come to the next question. Second Roman. Use the factor theorem to determine whether g of x is a factor of p of x, where p of x is equal to x cube plus 3x square plus 3x plus 1, and g of x is equal to x plus 2. This is the second Roman second question. Second question. I am not explaining second Roman first question and third question. In the Roman number 2, there are totally 3 questions are there. Here I am explaining second question in the second Roman. I am not explaining first question and third question in this Roman. You try the questions. Okay, my dear children? Right. This question is also same as that of the first question. Same that of question number 1. Here we have to check, we have to examine whether here this polynomial is a factor of this polynomial or not. Understood this question, my dear children? Right. Here already given this is a p of x. That is why it is not necessary to assume here. Already given p of x is equal to. Okay, my dear children? So let us find g of x. Let us find g of x. What is the g of x here? X plus 2. So x plus 2 is equal to 0. We have to write this equation. They don't give to write this equation and solve it. They won't give in the question. We have to recollect the knowledge of finding 0 of a linear polynomial. Understood this step, my children? Why we are writing this equation? Okay, right. Now we have to solve this equation by sending plus 2 to RHS. We are moving plus 2 to RHS. It becomes minus 2. So x is equal to minus 2. Here we got the value of x. What is the value of x here? We got minus 2. So we have to substitute minus 2. X is equal to minus 2 in p of x. It means here we are finding remainder. Understood this point, my dear children? Right. So put x is equal to minus 2 in p of x is equal to x cube plus 3x square plus 3x plus 1. Then we get this step. So in this p of x, put x is equal to minus 2. So p of minus 2 is equal to x cube is there. So minus 2 whole cube plus second term is 3x square plus 3 into x means minus 2 whole square plus third term is 3x. So 3 into minus 2 and fourth term is plus 1. Understood this step, my children? Just I substituted x is equal to minus 2 in the polynomial p of x. Understood the step, my children? Right. Now, let us find the values of each and every term separately. What is the first term here? Minus 2 whole cube. In rough work, I am finding the value of this first term. Minus 2 whole cube. What is meant by minus 2 whole cube? Minus 2 into minus 2 into minus 2. Then what will you get? Minus into minus plus plus into minus minus. So finally you get minus sign. Understood that part, my dear children? After that we multiply numbers. 2 into 2, 4. 4 twos are 8. So finally we get minus 8. So that is the value of the first term. Now let us find the value of this second term. What is this second term? 3 into minus 2 whole square. 3 into minus 2 whole square. I wrote that terms separately in the rough work. So 3 into, what is meant by minus 2 whole square? Minus 2 into minus 2. Understood this part, my dear children? Right. So plus into minus, minus, minus into minus, plus. So finally we get a positive number. Next we multiply numbers. 3 into 2, 6, 6 into 2, 12. So this is the value of the second term. Understood this part, my dear children? Right. So we found the value of this first term here, minus 8. So I wrote here minus 8 plus value of the second term also I found here, plus 12. Here 3 into minus 2. What will you get here? Minus 6. That is why I am not doing the calculation part in the rough work. Directly I am writing 3 plus into minus, minus 3 into 2, 6. Understood this term, my dear children? Right. Plus 1. Understood this step, my dear children? Right. Now, plus 2 plus 1. We are adding the positive numbers. What will you get here? 13. After that, we add negative numbers. Minus 8, minus 6. What will you get here? Minus 14. Understood this step, my dear children? Right. 13 minus 14. What will you get? Minus 1. Minus 1. Is it a 0? No, it is not equal to 0. Here we got p of minus 2 is not a 0. So it means you are not getting remainder 0. Therefore, by the factor theorem, g of x is equal to x plus 2 is not a factor of p of x. That is equal to x square plus 3x square plus 3x plus 1. Understood, my dear children? Right. Now come to page number 44 in the textbook. Page number 44. Roman number 3. Roman number 3. In this Roman number 3, there are 4 questions. There are 4 parts are there. I am explaining second part of the question. I am explaining here second part of the question. You try the remaining sums same as this question. Okay, my dear children, listen the steps carefully. You follow the same steps for the remaining sums also. Okay, my dear children? Right. Find the value of k. Find the value of k if x minus 1 is a factor of p of x, where p of x is equal to 2x square plus kx plus root 2. Understood the question, my dear children? What is given here? This polynomial is a factor of this polynomial. In that case, find the value of k. Here we have to find this value of k. Understood the question, my dear children? I am telling you many times. First to read the question well. Many times read again and again till you understand the question well. Okay, my dear children? Right. What is given here? X minus 1 is a factor of p of x. I wrote the sentence. Whatever is given in the question, I wrote that sentence here. Understood this step, my dear children? Right. Let us find 0 of x minus 1, because we have to substitute the value of x in the given polynomial. That is why we are going to find 0 of this polynomial. So how can you find the 0 of the linear polynomial? We write the linear polynomial is equal to 0. We have to write this equation. Okay, my dear children? Right. From this equation, we have to find the value of x. So if you send minus 1 to RHS, we get 1. So x is equal to 1. This is the value of x. We have to substitute this number in the given polynomial p of x. So as x minus 1 is a factor of p of x, we have p of 1 is equal to 0, because reminder, I told you many times, p of a is equal to 0. P of a means remainder. So remainder is equal to 0 by the factor theorem. By the factor theorem, we get this equation. We have to write this equation. Understood this step, my dear children? Right. This implies in LHS P of 1. P of 1, P of 1 means we have to replace x by 1. So 2 into 1 whole square plus k into 1 plus root 2. In LHS, we found p of 1 is equal to 0 when we write RHS part as it is. Understood this step, my dear children? Right. So this is the first term, 2 into 1 whole square. What will you get here? 2 only. Plus k into 1, k only. Plus root 2 is equal to 0. Understood this step, my dear children? Right. From this equation, we have to find the value of k. So k is equal to, we are sending these two terms because we cannot add these two numbers, 2 plus root 2. We cannot simplify further. So k is equal to, if we are sending these two terms to RHS, it becomes minus 2 and minus root 2. Minus 2 minus root 2. This is the value of k. Therefore, k is equal to, I have taken minus 1 common factor, 2 plus root 2. This is the value of k. Understood, my dear children? Right. Now come to the next question, next Roman, that is Roman number 4. In this Roman number 4, there are 4 parts. There are 4 parts, or there are 4 questions. If you observe the 4 questions, they are quadratic expressions. They are quadratic expressions. We have to factorize them. We have to factorize them. So, for example, I have taken third part, third question. I am not explaining here first, second and fourth. I am explaining here third part or third question of this Roman number 4. Okay, my dear children, you follow these steps for the remaining questions also. Listen these steps, my dear children. Are you ready to listen the solution to this question, my dear children? Right. Factorize 6x squared plus 5x minus 6. If you observe, this is a quadratic polynomial. And second case, I told you, it is not a monic quadratic polynomial. It is not a monic quadratic polynomial because here a coefficient of x square is not 1. If coefficient of x square is 1, then the quadratic polynomial is said to be monic quadratic polynomial. Whereas here the coefficient of x square is 6. So it is not a monic quadratic polynomial. In this case, we follow these steps. Whatever the quadratic polynomial which is not a monic, follow these steps. Okay, my dear children. So listen these steps, my dear children, to factorize this quadratic polynomial. So in this polynomial, already terms are they are arranged in a correct order. It is in the standard form. Okay, my children, x square term, next x term, and the last constant term. So we are going to split the middle term, that is x term. So before going to split the middle term, we have to follow these steps. First of all, we have to identify sign of the constant. What is the sign of the constant here? Minus. It helps a lot in selecting the factors, so this sign is also an important sign of the constant is minus. Okay, my dear children, keep this apart. Next, second step is we have to find coefficient of x square into constant. Here in this second step, we are finding the product of coefficient of x square and constant without taking here sign. We are ignoring sign of the constant. So 6 into here constant is 6. Not, we are not taking here minus 6. Directly 6 only. So 6 into 6. What will you get here? Number 36. So this is also important number. For this number, we have to write the factors like this. We have to write this number as a product of two numbers as many ways as you can. So 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. These are all possible ways to write this number as a product of two numbers. Okay, my dear children, understood this one? Right. After that, this sign play a important role. What is this one? Minus. So we have to subtract big number minus small number. 36 minus 1. What will you get here? 35. Here big number 18 minus 2. 16. Here big number is 12 minus 3. What will you get here? 9. 9. Big number 9 minus 4. Between these two numbers, between these two factors, I kept here minus sign. This is sign only. Understood this, my dear children? Right. 5. 6 minus 6. 0. These are the 5 results we got here. 35, 16, 9, 5, 0. Out of these results, now come to the middle term. What is there here? 5. So, where you got here 5 in this step? In this case, we got to 5. In the remaining cases, we are not getting 5. So we have to choose these two numbers, 9 and 4, to split the middle term. To split the middle term, we have to use these two factors only. Understood this part, my dear children? Right. So we write first and last terms as it is. We are splitting the middle term. So 6x square plus 6x square plus 6x square plus 9 minus 4x, 9 minus 4x, 5x means 9x minus 4x minus 6. Then what will you get here? 6x square by distributive property, 6x square plus 9x. Here what will you get here? Minus 4x minus 6. Minus 4x minus 6. Here what will you get here? From the 4 terms you get. In this step you get 4 terms. 6x square is the first term, 9x is the second term, minus 4x is the third term, and minus 6 is the last term. For these 4 terms we are writing prime factors. Do you know how to write prime factors? Right. So 6 can be written as 2 into 3. X square means x into x. In rough work, I am doing that part here. Second term, 9x. 9x, how can you write? As a product of prime numbers, 3 into 3 into x. Understood this step, my dear children? Right. Now come to the third term. Minus 4x. Minus 4x is equal to minus 2 into minus 2 into 2 into x. We can write this minus 4x like that. Similarly, last term is minus 6. Minus 2 into 3. Understood these parts, my dear children? Right. Now, from the first two terms, from these first two terms, what are the common factors here? 3 is common factor and x is also common. So, 3x. Finally, we can say that 3x is a common factor. So, we can take it out, that common factor, 3x. If you take it out, the common factor, what will you get here? 2x, 2 into x, 2x plus, here plus sign is there, so you can write plus 3. From these two numbers, from these two terms, we can take minus. We can take here minus. So minus 2. From the last two terms, minus 2 is common factor. Then we get here 2x plus 3. 2x plus 3. Then what will you get here? Again 2x plus 3 is common factor. 2x plus 3 is a common factor. 2x plus 3 is a common factor. If you take it out, 2x plus 3, what will you get here? 3x minus 2. So these are the factors of this quadratic expression or quadratic polynomial. This is one factor, 2x plus 3 is one factor, 3x minus 2 is another factor of this quadratic polynomial. Understood, my dear children? Right.